All right, on this problem, we have three states that are cooperating to build a dam to provide water to communities currently lacking adequate water supplies. All right, we got seats on a 12-member water authority. That is what you're going to be apportioning, the 12 seats. And they're going to be assigned according to the number of customers in each state who use the water from the project. Okay, so try to use different colors here. There are 60,000 customers in state A and 53,000 in state B and well, how about orange? And then you got 42,000 in state C. All right, so the first thing you have to do is add all these numbers up to figure out the total population. And that adds up to 155,000 people. All right, so that is step one. Now, step two, for state A, you are going to take the 60,000 people and divide it by the total number of people. You're trying to figure out what percent is 60,000 out of 155,000. So when you divide, you get the percentage. But what I'm going to do is I'm going to go ahead and multiply that times the 12-member board. I'll do all this on my calculator. I'll take the 60,000 divided by 155,000. My calculator is going to say 0 point something or other. That would be the percentage. And then we want to know what percent of the 12. So we multiply that times 12. And then I usually take it out to the hundredths place. I see it's 4.64. So right now I know that state A, when you look at the whole number part right here, that's how many seats state A is going to get. They're going to get 4 seats. And so now I'm going to move on to state B. I'm going to take the 53,000 for state B, divide it by the 155,000. That division right there will give me the percentage. And then I take that number times the 12. And it's sitting in my calculator, so just let the calculator do it all. And that comes out to be 4.10. You don't have to do any rounding. Just take it out 2 places in case you have to compare. When you go to compare the fractional part, like you might have, if you just wrote down 4.6 for that first one, and if this one had come out to be also 4.6, they match not only in the whole number position, but in the tenths. So I need to take it out to the hundredths to see which one's bigger. And if they match there, you then have to take it out to the thousands. So, but I will tell you, I've never had a problem going further than the hundredths place. So hundredths should do it. And so we get 4.10. And again, this is the whole number. It's 4. So state B will get 4 seats. And now we come on down to, whoops, wrong one. State C, which has 42,000 people. Divide that by the 155,000. That gives you the percent. Multiply that times 12. And that one comes out to be 3.25. And so the whole number there is 3. So they're going to get 3 seats. But when you add 4 and 4 and 3, that only adds up to 11. And actually, maybe I should use the blue here since I'm adding them up. When I add this up, it only adds up to 11. It's supposed to add up to 12. So there is one more seat. And so for the extra seat, you now have to go back and look at the fractional parts. And so, let's see, let me use a light yellow. There we go. So now I'm going to look at, I got 0.64, 0.10, and 0.25. This one is the largest, so they're going to get one more seat. So A is going to end up with 5, and B is going to end up with 4, and C is going to end up with 3. And when you add those up, when you do add these up, 5 and 4 and 3 does add up to 12, so I've apportioned them correctly. So, and of course, you'll put those answers, you know, in the boxes in my math lab. And that is number 4.